Hello everyone, welcome to lecture number 10. This lecture we will discuss a theorem of named as Cauchy mean value theorem. Lecture number 10. So our target is to study Cauchy mean value theorem. So later on I will abbreviate this theorem as CMVT, that stands for Cauchy mean value theorem. So statement is as follows. Let f comma g are real valued function defined on closed interval a comma b to r such that number 1 f comma g are continuous on closed interval a comma b. Number 2, f comma g are differentiable on open interval a comma b. Number 3, f dash x is not equal to 0 for all x belongs to open interval a comma b. Then theorem says that there exists C belongs to open interval a comma b such that g dash c upon f dash c is equal to g of b minus g of a upon f of b minus f of a. Let's write down. We have to prove this. If f and g satisfies the condition 1, 2, 3, then definitely we can say that there exists C, a real number between a to b, such that g dash c upon f dash c is equal to g of b minus g of a upon f of b minus f of a. So let's prove this. So firstly we claim that f of a is not equal to f of b, surely. So let's prove this claim. So proof of claim. So I need to show that f of a and f of b are not equal. So how to prove this? Suppose they are equal. Suppose f of a is equal to f of b. I will use a method of contradiction. So if f of a is equal to f of b, also we know that from the previous slide, also we know that about f is continuous, f is differentiable, and if I say here f of a is equal to f of b, where it is in numbers in the next slides, yeah, and if I say f of a is equal to f of b, then f satisfies the hypothesis of Rolle's theorem straight away, because f is differentiable on open interval a comma b, f is continuous on closed interval a comma b, and f of a is equal to f of b. These three conditions hypothesis are basically a hypothesis of Rolle's theorem. This would imply there exists C belongs to open interval a comma b such that f dash c is equal to 0. Rolle's theorem says this, which is contradiction. to given 3 to given to given 3, because in the statement we have straight away said that f dash x is not equal to 0 for any x, and here we are saying that there exists a real number such that f dash c is equal to 0, which contradicts. So why we got a contradiction? Because of our assumption f of a is equal to f of b. So this assumption is wrong, so f of a is not equal to f of b. So this would imply f of a is not equal to f of b in any case. So now if f of a is not equal to f of b, then now we will define a function called phi of x as g of x plus a times f of x, where a is constant real number. Such also, while defining this phi, we should make sure that such that phi of a is equal to phi of b. We will construct phi in such a way that phi of a is equal to phi of b. So let me number this as number 1. Now since phi of a is equal to phi of b, so this would imply g of a plus a times f of a is equal to g of b plus a times f of b. What I did, I substituted phi of a, this is phi of a, and this is nothing but phi of b. So again you replace x by b, so you'll get phi of b, and it is mentioned that phi of a is equal to phi of b. So what I'll do, I'll take this g of a this side, so what I'll get, g of b minus g of a, I'll this side, and this a times f of b I will take this side, so I will have a f of a minus a f of b. Now I'll take minus a common, so I will have f of b minus f of a is equal to g of b minus g of a. Now this bracket I'll send it to denominator, so I'll get minus a is equal to I want to eraser, just minus a is equal to g of b minus g of a upon f of b minus f of a. That was in my denominator. Let me check. Yeah, g of b minus g of a, you could see that divided by f of b minus f of a. So let's number this as an equation star. Now what I will do is as follows. Now you see this phi of x which I have shown is a combination or linear combination of f and g. We know that f and g are continuous and differentiable. Implies by algebra of continuity and differentiability, phi is also continuous and differentiable. Moreover, phi of a is equal to phi of b. So phi is continuous, phi is differentiable, phi of a is equal to phi of b. This three condition leads that phi satisfies the hypothesis of Rolle's theorem. So we can apply the Rolle's theorem on phi. So let me write down that. So since f and g are continuous on closed interval a comma b, this would imply phi is continuous on closed interval a comma b. Also f and g So let me call this as number 2. Also f and g are differentiable on open interval a comma b. That would imply phi is differentiable on open interval a comma b. So let me call this as a 3. So this is number 3, this is number 2, and this is number 1. So from 1 to 3, phi satisfies Rolle's theorem. That is, there exists C belongs to open interval a comma b such that phi dash C is equal to 0. But what is phi? Phi is given to be g of x plus a f of x. So phi dash x will be g dash c plus a times f dash c is equal to 0. Let me go on next slide. So I got g dash c plus a times f dash c is equal to 0. Now what I will do, I will take this a this side, so I'll have minus a times a minus a is equal to g dash c upon f dash c. Let me number this as double star. Now you know we have already mentioned in a star we had one star. Yeah, so this is my star which says that minus a is this, and this is my double star. So from star and double star, we get g dash c upon f dash c is equal to what is in g of b minus g of a upon f of b minus f of a. G of b minus g of a upon f of b minus f of a, which completes the proof. Let's have one small example. Verify Cauchy mean value theorem for x square and x cube in the interval 1, 2. Solution. So let f of x is equal to x square, g of x is equal to x cube. So f and g are polynomial. So being a polynomial, they are continuous and differentiable on closed interval a comma 1 comma 2 and open interval 1 comma 2. So being polynomial, f and g are continuous on open interval, so close interval 1 comma 2 and differentiable on open interval 1 comma 2. Right, so also f dash x which is equal to 2 of x, which is not equal to 0 for all x belongs to open interval 1 comma 2. So for any value 2x between 1 to 2, 2 into x is not equal to 0. That's very clear. So we can apply the Cauchy mean value theorem. So by Cauchy mean value theorem, we need to find C belongs to open interval 1 comma 2 such that g dash c upon f dash c is equal to g of b minus g of a upon f of b minus f of a. Now let me calculate what is g of b. So here g of 2 minus g of 1 upon f of 2 minus f of 1. So g dash c, g is x cube, so g dash x will be 3x square, so g dash c will be 3c square. F is x square, f dash will be 2x, so it will be 2c is equal to g of 2 minus g of 1 upon f of 2 minus f of 1. G of 2, g is x cube, so g of 2 will be 8 minus 1. F is x square, so it is 4 minus 1, so it is 7 upon 3. So one of the c will get cancelled, so 3 c square will 3c by 2 is equal to 7 by 3. So this would imply c equal to 14 by 9. 14 by 9 means hardly, it is something 1.6. Of course this you could see that it is belongs to open interval 1 comma 2. So this would imply f and g satisfies Cauchy mean value theorem. Hence CMVT verified. This complete lecture number 10. Thank you.